Who are joining, please go on mute. And if you have any questions or any clarification, please ask. Okay.
Yes, Srinivas, ready?
Okay. Started recording.
Yes.
Okay. Virtualization concept. Session all about virtualization concepts. What are the requirements? What we need to understand before going to virtualization. What is the OS? We understand that we selected a hardware. On top of it, we install an operating system. Why we install an operating system? To perform some application, execute some applications. In this particular layer, if you see here, the first hardware layer. Hardware layer, what we talk about, what we discuss, there are 5 major components. What are the major components? Motherboard, CPU, RAM, network, storage. These 5 components are major to understand what are the hardware components, on which hardware I am installing in a software operating system. Okay, so first we understood that what is a hardware components, and then we install operating system, any operating system, either it can be Linux, it can be Windows, whatever operating system. We install an operating system. Why we install an operating system? To run certain applications, certain process. If you see here, what is this application? Different applications, different processes, what they are going to do. Each application, whatever the application, for example, you are opening your laptop, okay? On the laptop, you are opening browser, you are opening copying some data, whatever it may be, the background process, whatever the application related background process, it is going to consume, it is going to talk to that application operating system layer. That operating system layer, it is going to assign a hardware resources according to the application requirements. Here you need to understand how the application is coordinating the software operating system layer by accessing the hardware layer. Accessing the hardware layer in the sense it is executing application on the software layer by using the hardware resources. What are the hardware resources? To execute an application, it requires some CPU instructions. It requires some RAM space. It requires some network to send the communication, to receive the communication. And all those things, it is going to happen by accessing the data from the storage. So whatever the application it is going to execute, for each application, these 5 components is going to share for each application. There are multiple applications, multiple processes are going to run on a system. How the applications is sharing the resources, that you need to understand. Why it is very much important in virtualization, we need to understand how resources are sharing. In an operating system, in a laptop, don't go for server, consider your laptop. In our laptop, in our system, desktop system, how applications, different applications sharing the resources. There are different applications, but all applications are working together by accessing respective resources on hardware layer. How they are accessing the hardware layer? Through an operating system. Operating system is going to creating a handshake between the application and the hardware layer, so that it is whatever the application it is requires resources, it is in providing by collecting the information from the hardware layer. So that is the information, how many applications you are going to load, you are going to execute on top of an operating system. That depends upon how many resources are available. Resources in the sense, here I'm going to talk about the CPU, memory, RAM, storage, network, and all those things. All applications are using the same hardware resources. When the hardware resources, how many applications I can install, how many applications I can execute at a given point of time, it is all depends upon the capacity of the hardware layer. how fast it can support, how much memory it can support, the utilization, the CPU utilization. If you are using only one application, how much CPU is consuming, how much memory is consuming, how much storage is occupying. So all these matters, that in the sense, the same hardware resources are used by different applications here. Okay. This is a basic understanding the structure of how applications are accessing the hardware layer through an operating system. In virtualization, what it is going to replace? In virtualization, we are going to, we need to understand first the basic concept of how the resources sharing is happening between the application layer to hardware layer. What is playing in a middle layer, that's operating system layer playing an important role, sharing the resources as per the application requirements. This is a basic understanding on your system, desktop system itself. No need to go to server. So if you understand this basic concept, we are going to replace this component with virtualization components. Virtualization components, what virtualization components is going to come into picture here? The hardware layer is going to be same. How CPU, memory, and the network storage is the same. The operating system layer, instead of Windows operating system, Windows instead of Linux operating system, what I'm going to do, I'm going to load a virtualization operating system. What is that virtualization operating system? We'll talk about. Okay, we are going to replace this operating system layer with virtualization layer so that the applications here, you mentioned here application 1, application 2, application 3, number of applications. These applications I'm going to replace with the virtual machines. Virtual machines in the sense virtual hardware. By using virtualization operating system, I'm going to create a virtual hardware. How am I able to create a virtual hardware? Virtual hardware is nothing but you should understand physical hardware. What is a physical hardware? A system, a server is consist of a box and motherboard. And what are the motherboard is there on the top of motherboard? CPU, how it is going to insert, how the RAM is going to insert, how the storage is connected, how the network is connected. These are the devices. It's a physical component. You need to understand the physical layer, basic understanding. If you are not able to understand the basic physical layer, you cannot imagine what is a virtual hardware. Here, from here onwards, it is all about imagination. You need to correlate with the physical components. If you are not able to understand the physical components, you cannot imagine how the virtual hardware is going to be. Here, virtual hardware is nothing but, here application, what is the application? Application is nothing but yes, software code, some software files. I'm going to execute Microsoft Office. I'm executing Microsoft Office. How I'm executing Microsoft Office, or I'm able to open web browser. How I'm able to open web browser? It is an application. Application in the background, what it is? Software code. The software files are executing in a sequence and then sharing the resources and giving a page for my web page interface. I'm opening a Microsoft Word. I'm able to type the letters. How that imagine what is background happening? It is a combination of software code. The similar way in virtualization also, the applications are going to replace with the virtual systems, virtual hardware, virtual server, virtual machine. I'm going to calling as a machine. My laptop is a machine. My laptop has a monitor. My laptop has a motherboard. My laptop has a hard disk. We know that the system is there now. We are going to talk about virtual machine. Virtual machine is nothing but it is going to have a system, it is going to have a monitor, it is going to have a motherboard. But how they are going to combine together? It's a software files. How I am able to create those software files and making them as a virtual machine. That's what the virtualization layer operating system is going to do. How many applications I'm going to execute on a server? If number of applications need to execute, I need sufficient resources should be available on the hardware layer. So it all depends upon how many virtual hardwares I can deploy on a virtualization layer. It all depends upon available hardware resources and hardware layer. So you need to convert, you need to imagine how these things are going to work. Once application is replaced with the virtual machine, once the application layer is replaced with the virtual machine in the sense, I'm building in a virtual machine by using the virtualization operating system, by using hardware layer, physical hardware layer. So once the virtual hardware is ready, I can do operating system installation, whatever as per my requirement. I can install Windows operating system. I can install server operating system, Linux, anything. Whatever the operating systems I can install, the virtual hardware is ready. So once the virtual hardware is ready, I'm able to install an operating system on top of it, virtual hardware, virtual machine. Okay, then once the operating system is ready, why I'm doing an operating system installation? To install a DB server, to install a web server, to install some blah blah application servers. So what is requirement here? To install, to execute some application, I need an operating system. To run an app, to install an operating system, I need a hardware. What hardware? Till now we know that it is a physical hardware. Now what I'm going to replace the physical hardware? I'm replacing with virtual hardware. How that virtual hardware is going to come into picture? Simple understanding. To understanding the how the virtualization layer, how the hardware layer, how the application layer is going to work, first we need to understand that. Then we are going to imagine replacing these components with virtualization concepts, virtualization issue. Okay, so coming back to this PPT, here you can see here the hardware layer and software layer. Software layer in there is nothing but operating system. On top of it, operating system, software related processes, application related files. Who is going to use that applications? Who is going to use system processes? Number of users. Why server operating system you are going to use? Why not desktop? Desktop server or desktop system is a single user interface, whereas in server operating system is a multi-user interface. Okay, we understood that during the server operating system installation. Now I'm going to correlate how the application layer, how the hardware layer is going to work, how these things are going to replace in virtualization layer, virtualization world, how these things are going to change. To understand the virtualization, you should understand, you should correlate what you have, desktop system, hardware. You should imagine how the things are going to in place in virtualization layer. I'm simply replacing operating system layer and application layer with virtualization concepts in going classes. For that, you need to understand what is happening, how the applications are sharing the resources. Okay, next one. So, what type of servers? Till now, we did in lab installation previous sessions. What we did in previous labs, we install an operating system on top of it, a hardware. If you are installing hardware, operating system, Linux or Windows, whatever the operating systems you are going to install, there is a concept comes in picture. Is it a physical hardware or virtual hardware? But whenever you are talking about virtualization concept comes in, virtualization operating system concept comes in, there is no point of virtual hardware. Why we are going to talk about why it should be only physical server, we'll talk about. Okay? But the concept is here in virtualization, we have to talk about only physical server only. Why we are choosing physical server? Why not virtual server? Why we are using virtualization? Why necessity? What is the necessity of virtualization? We'll see. Before going further, what are the server models are available? What is servers? There are different physical server models are available. Very olden days, we call it as tower servers. Tower server is just like our CPU desktop system in our home. It's a tower box, and box, it is a capacity tower server, we call it as. There is one more concept, rack servers. Rack servers, different concepts, 1U rack, 2U rack. I'm going to share the links, YouTube links, I'm going to share in the WhatsApp group. So to understand what is a rack server, how they are going to place in a rack. Rack is nothing but it's just like a iron shelf. In iron shelf, this particular rack server, 1U rack server, they are going to place and fit the screws. Okay, similar way, 2U rack server, 4U rack server. 4U, 1U is nothing but it is a thickness of the server, and capacity also it is going to come into picture. How much memory it is going to support, how much CPU it is going to support. That is rack servers. These rack servers also is a old models. Okay, whenever we are going to come into virtualization, this virtualization all talks about blade servers, blade architecture, off-height blade server, full height blade server. This is a blade concept. That in the sense, tower server, what is a tower server? Hardware. What is a rack server? We call it as some servers, we call it as a rack server. We call it as some server as a blade server. Why the blade servers are more popular in virtualization environment, we will see how the things are going to replace. What are the benefits it is going to provide in blade server architecture? While working on virtualization layer, we are going to create number of virtual servers on a hardware. So that hardware should be high performance. That hardware should have a high capacity in concepts of memory, in concepts of network, in concept of CPU, all those concepts. If the hardware layer is high end and more resources are available, what it is going to support? It can support number of virtual servers. What is number of virtual servers? We talk about first to understand the virtualization. First, we need to understand basic architecture, how the hardware layer, operating system layer, applications, how application are sharing the resources of hardware layer. If you understand how the number of applications are sharing the resources on your laptop system or desktop system, you can correlate the same things. You are going to replace that applications, number of applications, replacing virtual machines. Okay, come back to this hardware server model. These are server models. We talk about only server models. Now, what is there in the server? What are the main things we need to understand in the server? In your desktop, there are certain components you should understand, like what is a motherboard, what is a CPU, what is a RAM, what is a network card. All those is the concepts. We need to understand the hardware components a little bit more. We already covered the hardware session, starting of Windows Server Administration, but I'm going to repeat the same points again here. It is very much important for the virtualization understanding. Okay. So data center in the sense, what is a data center? Data center is all talks about number of servers. Data center is nothing but one room. Data center is nothing but one building where all servers, all physical servers are going to place there. Number of servers. If I'm going to use a tower servers, what is a tower server? It's a just like box. If I'm going to place the tower server, how many tower model servers I can place in a room? How much size it is going to occupy? Footprint to place servers, racks, and enclosure. How much space is required to place a tower model server, to place a rack servers, to place an enclosures? The footprint, it matters because data center is nothing but where it is going to provide an room and all facilities, power backups, and all network facilities in a particular building, wherein they are going to place all physical servers or network equipment, all storage servers in that particular place. So here, what we need to understand, what is data center? Data center is nothing but one location refers or one building or one room. They are going to call it as a name servers. In my data center, how many servers are available? What is the footprint available? What is the network equipment is available in data center? Power requirement to power to connect the servers to physical servers, network equipment, everything. We need to provide a power requirements. What it is going to be number of servers, all the AC rooms, then what are the servers in any organization, small organization also. For server room, they are going to make it as a AC room because the servers are going to run most heat. So the cooling fans are going to run, for power plants are going to run to cool that processor components, to all the hardware components. For that AC required, how much AC is required if the number of servers are increased, AC requirement to minimize the heat. According to that, availability components are all above components. The cost factor also coming into picture. Number of servers, if it increases number of servers, professionally it is going to increase the all factors. Footprint, number of connectivities, number of power requirement, number of AC requirements, everything it is going to increase. Thereby it is going to increase cost also. So data center is nothing but how many hardware server devices, how many network devices, how many things are in infrastructure, what it all consists that we call it as a data center. In my data center, these many servers. To maintain a single room, I can call it as a data center. To maintain one particular building, I can call it as a data center. Okay. Why virtualization? Why virtualization? For example, if you see the desktop system, we need to consider how resources are in utilization. If I open this desktop on my task manager, what I can see, what is my performance in this particular place? I'm using the CPU 56%, 57%. Memory is half of the percent, 75%. These are all the parameters on a server. If you consider, if I'm going to purchase a hardware, a tower model server, what will happen? I'm going to install it for a web server. I'm going to purchase a hardware to install web application. How much resources it is going to consume that web server? I'm going to purchase 1 lakh server, hardware server, and how much resources it is consuming. So it all depends how the optimization, how I can use the effective utilization of resources. The same single server, instead of using web server, what I'm going to do, the same server, I'm going to install a virtualization operating system. Thereby, on top of it, I'm going to install virtual machine. I can create number of web servers in the same hardware. That in the sense, I'm going to utilize, optimize resources. Optimizing in the sense, whatever the capacity is available on the server, I'm going to utilize complete at least 80%, at least 70% of the utilization on the respective hardware, so that reduce the cost of this particular environment. If I have same server, same hardware, I'm going to replace with a number of servers by using operating system, virtualization operating system. What I'm going to achieve by using single tower server, I'm going to install 8 virtual servers. That in the sense I'm going to eliminate additional 7 tower servers. 7 tower servers I'm going to eliminate in the sense I'm going to save the footprint. I'm going to save the power connections. I'm going to save the heat, reduce the heat. I'm going to reduce the AC consumption. So this is the benefit why virtualization I should go. First concept is effective utilization of resources. The second concept is reducing the footprint. In a data center, if I need a server, if 10 servers if I required, how much space I need one room to accommodate 10 tower servers. Imagine the enterprise environment. How the servers, number of 1,000 servers. Imagine 1,000 servers to place in a data center. How much space is required? How many AC environment, power consumption? All those things cost is going to increase. By all the consideration, this 1,000 servers, I'm going to replace with 20 servers. That's the power of virtualization. These 1,000 servers, I'm going to accommodate in 10 servers. How it is possible? What are the things I need to do? What are the things I need to make this happen? That in the sense, 1,000 servers in a building, I'm going to reduce the entire building, I'm going to reduce to single room. Entire building, how much footprint I'm going to save, how much AC I'm going to save, how much power consumption I'm going to save. That's where the concept comes in. Why virtualization? Effective utilization of resources and reduce the footprint, reduce the cost, reduce the power consumption, all factors. So it is going to save the entire environment, how the effective utilization come into picture, how the 1,000 servers are going to come into 10 servers. We are going to see that concept. So because these all things are going to happen with by using the virtualization, we are going to understand this, how these things are happening in virtualization. That's the reason we are going to understand the server models. Which server is going to provide more? For example, 1,000 servers, I'm going to make it as a 10 servers. That in the sense, for each server, I'm going to use for 100 servers. To use 100 servers in a single hardware, how much hardware should be there on the particular server to support 100 virtual servers? That's the reason. What is the power of tower server? What is the power of rack server? What is the power of blade servers? Tower servers is going to occupy some footprint. Rack server is going to occupy some footprint. At the same time, blade server, how much it is going to occupy footprint? We are going to see that now. Before going to next slide, I'm going to see the how the tower server, how the blade server is going to have. Just going to, let's have a look. I have links. I'm going to share those links. You can go and do your practice by going through these links. I'm going to share these links. This is this is a blade servers, the toppest high performance blades. Now the Cisco is playing a top vendor, like market share. It's occupying more market share by providing the Cisco blade enclosure, Cisco blade services. Why the Cisco is top amongst other blade vendors? Like all hardware vendors supports blade architectures, HP, IBM, any different Dell, all other vendors are there, but Cisco is dominating the blade architecture world. Why it is dominating? What is the feature it is going to support? Okay, because you need to understand. You should understand first what is blade, and then you can go through that what is the features it is going to provide support. I'm going to share the links so that you can cross verify what is the advantage of blade servers, what is the advantage of importance of the blade architecture. Let's see. I'm going to show you simple how the enclosure, this blade enclosure, how it is going to look like. This is a blade enclosure, Cisco uses blade enclosure, how these servers are going to place, how the things are going to connect, all those things we can see. Okay, you can click on this. What is those importance? For example, this is a KVM connector. You can click. This is a Cisco website. It is providing an imagination like how the Cisco enclosure is going to look like, how the off-white blade is going to look like, how the full height blade is going to look like. You can navigate. You can do like this. I'm going to share the link so that you can do all this information. Whoever monitoring, you can type that particular website information also. What I'm going to do, how this blade, off-white blade, full light blade. See this is the architecture, how the inside the blade server. See how many memory modules are available, how many CPU modules are available, how many CPUs. There are two CPU sockets. If you click on here, this is CPU socket. See here, Gen Intel, Gen processor, GN processor. What is this? Memory modules, DIMMs. These are the DIMM slots. These four corners, these are DIMM slots. How much memory it is going to support off-light blade, how much memory it can support. Here you can see 90 up to 9 TB of memory. Up to 9 TB of memory. Imagine how capacity, how cost involves in this particular off-light blade. 9 TB. We know that server is going to work, desktop system is going to work on 2 GB memory. But whatever the server we are going to use for virtualization, it should be high resource availability. 9 TB of memory and CPU, how much cores it is going to support, how many processors it is going to support. This blade has a specification you can go through. General motherboard, general processor, we call it about 2-core, quad-core. 2-core core means one physical CPU supports only 2 logical cores. But in this particular CPU, if you consider this particular CPU supports 48 cores, 58 cores, it depends upon the model. So that is the capacity of the server hardware. We need to look for the virtualization layer. What is my organization requirement? This is a half height blade. Let's go through some full height blade. Simply how the removing the, see in half height blade only 2 processors, but full height blade, see how many processors are there? 4 processors, 4 sockets are available. 4 sockets are available. I can install 4 CPUs. How many DIMMs are available? If I click on DIMM slots, what is the DIMM slots available? See, previously off-height only supports 9 TB of memory. Now it is full height supports 18 TB of memory. That in the sense, whatever the blade server I am going to use, that blade server is capable enough to withstand number of virtual servers. By using this physical server, I am going to create a virtual server. So each virtual server requires 4 GB RAM or 20 GB RAM according to my application. If it is a DB server, how much memory is required? Maybe 24 GB RAM or 4 CPUs or 8 CPUs. I'm going to create a virtual machine by using these physical resources. That's the virtualization, how it is going to work. Okay, so that you can understand there is no connectors for this blade server. See in the background, there is only just 2 connectors. There is no cable connector, there is no monitor connector, there is a keyboard connector, nothing. Just like a hardware hard disk, how it is a hard disk is going to have. If you see that external hard disk, it has going to have an USB connector. The similar way USB connector, this is going to have this particular connector, just as hard disk connector we call it as, just as mezzanine card we call it as for this blade architecture, mezzanine connector. This connector is going to sit in this particular blade enclosure. As soon as you insert this particular server, this hardware server into this blade enclosure, this is a blade enclosure. As soon as you insert the blade enclosure, how it is going to insert and how it is going to connect at the back end. Let me open one more link. There you can see live, like how the hardware is going to install. See, we are going to install this processors, RAM modules. See all these RAM modules, this particular portion. These are the DIMM slots. This particular portion we call it a socket. Okay, this is a connector at the background. and the server. See here, this particular connector. This is a connector where the enclosure, it is going to connect the enclosure. From this particular connector only, it is going to send the communication for network, for all the communication through this particular connector only. So that by I'm going to eliminate all cables, no network cable, no power cable, nothing. By using this single connector, I'm going to establish communication. See, all this processor is installing processor. See this DIMM modules, how many DIMM modules? 9 TB of memory, supports up to 9 TB of memory, in the sense how much each module it can insert in this particular module, so that I can get up to that maximum value. This server supports 9 TB of memory, in the sense how much memory DIMMs. These are the memory DIMMs. So once this memory RAM DIMMs are going to install this particular place, this DIMM slots, it's going to support according to the memory. This particular place, this is the hard disk. This particular server, how many hard disks it can be installed? 2 hard disks. If you see in this particular full height blade, there are 4 hard disks available. How many sockets are available in full height blade? 4 sockets are available. This is the inside of this particular blade. How this look like, how the hardware is look like. Why I'm showing this all these components? You should understand about hardware before working on virtualization layer. Without understanding hardware, without imagine how the physical processor look like, how the memory module is look like, you cannot imagine the virtual memory. You cannot imagine virtual CPU. You cannot imagine virtual hard disk. So first we need to understand the physical components, how the virtual physical components are look like, and then you can imagine the same components we are going to replace a virtual component. Virtual components is nothing but files component, software code. First we need to understand physical components so that we can understand virtual components. This is one thing. And other link, what I'm going to show you, live environment, wherein we can see how the blades, this is HP blade enclosure. See here how he is going to remove the blades, how he is going to axe, how he is going to pull the blades. By removing the simple lock, he is going to pull the blade outside of the enclosure so that he can insert the blade enclosure inside. This is a blade servers, half-height blade servers. In this particular enclosure, any enclosure, either Cisco enclosure or HP enclosure, any enclosure, there are how many servers we can insert in a single enclosure? Total 16 half-height blades. How many half-height blades I can insert in an enclosure? Any enclosure, either Cisco or HP or IBM or Dell enclosure, any enclosure, it can support total 16 blades, 16 half-height blades. 16 half-height blades in the sense, top layer 8, below layer 8. If I'm going to use full height blade, see he is removing full height blade. If he is removing full height blade, maximum full heights I can install in an enclosure, 8 blades, 8 full height blades. If I'm going to use half height, there is a middle separator is there. That separator is going to separate this layer in the enclosure so that I can insert number of half height blades. If I'm going to install full height, then I can see here below empty enclosure how it looks like, the base, how the base is visible. These are half height blades. If I remove the middle layer so that I can insert full height blade, that's an enclosure. So for any enclosure, any Cisco or HP or Dell or IBM, any enclosure, it will support 16 half height blades. If I'm going to use any one full height, that is going to reduce by 2 half height. Here what is showing is 2 half height blades enclosure, and he is going to use 12 half height blades. That's where. Even see the power supplies, different power supplies, how it is going to remove, see, even this is a power supply. By removing the power supply, why the number of power supplies, these 16, 18 blade servers, 16 blade servers are going to work in single enclosure. Look how much processor is required, how much redundancy is required. We are going to talk about all these components. So this is a physical understanding how these components are going to work. If you go to the background of enclosure, rear view of enclosure, I'm going to share these links in WhatsApp group. Just go through that and understand what is telling about how the things are look like. First, we need to familiar with this architecture, familiar with the what are the hardware components. Then only you can imagine the virtualization layer, how my virtual machine is going to get the resources. That capacity, how much capacity I should have in a hardware layer. What is a high-end servers I need to use? You need to think about all this concept. That's the reason I'm playing all this video for a better understanding of how the hardware, which servers, which hardware I need to choose for my virtualization environment. Coming back to this, so why virtualization? Why the server? See the footprint. If I'm reducing 10 racks of, can I install hundreds of virtual servers in a rack server? The capacity it can't withstand. There the concept comes in blade servers. There the concept comes in blade servers. So I'm going to talk about little more hardware basics again. What are the basics we already discussed in the session? If you are missing that session, go back to this sessions in my YouTube. You can have in a hardware class first section and second and third sessions talks about motherboard, CPU, memory, what is a core, what is socket, and all those things. I'm not going to cover all those components again now, but what are the components are required for virtualization? I'm going to concentrate on more on that virtualization concepts. For what are the required components? Just what is a BIOS, what is a motherboard, socket, core, hyper-threading. In CPU, these three terms, how it is going to place an important role. Just go back to the previous sessions where you can understand clear 1 hour session is there. You can understand what are the components for hardware, RAM, storage concepts, network concepts. Little more storage and network concepts I'm going to cover. Okay. See, this is a motherboard. We know how the socket need to identify what is the socket all about, what is the DIMM socket all about. For server hardware, what is the socket? That socket, what is a core? What is a hyperthreading? How many logical processors it is going to support? By seeing this motherboard, we should understand processor. You can go to Intel site, how many logical cores it can available for each core. Sites are available. I'm going to share this PPT as well in WhatsApp group so that you can Google it. You can understand how many cores a single processor can support. If you can't, mobile device processor, desktop processor, it can support 2-core, octa-core, max 8 cores. But in a server concept comes in picture, the cache, the instructions, CPU instructions, how many cores it can support, what is the power, because the CPU has to support number of virtual servers. So number of virtual servers it has to support in the sense, whatever the CPU you are going to select, whatever the hardware you are going to select, that particular hardware should have a high capacity. Then only the virtualization will work seamlessly. Okay. DIMMs, the server DIMMs difference, desktop memory modules are different modules. Storage. Here the storage concepts I am going to discuss in tomorrow's session little more about the storage concept and network storage concept very less. What is the things are required for storage? What is the network components? In network, I am going to discuss more about network because the most important topic, how the network is going to share the resources, how the network communication is happening from a single hardware, how the 100 servers or 10 servers or 50 servers are able to send communication from a single server network port. Single server network ports, how many network ports are available? Through that network ports, how the communication, all 10 virtual servers, all 100 virtual servers are, whatever the servers are there on that physical hardware, how does all 100 servers able send the communication to outside? So this storage concept and network concept. In initial class, the storage concept I discussed about only direct attached storage, that in the sense local storage. But in virtualization, we are going to talk about network attached storage and SAN. These two components very much important in virtualization. We are not going to use local storage, we are going to use NAS and SAN. Why we need to use NAS and SAN? What is the requirement for NAS? What is the requirement for SAN? Tomorrow session, I'm going to discuss on that. In the same time, network ports. What is the network components? What are the network components you need to understand before going for virtualization layer? The motherboard, processor, RAM, common. These out of 5 resources, these 3 common we can understand for anything. But for virtualization, storage and network, these 2 components plays an important role. Then only if you understand the network and storage concept well in clearly, then only you can understand, you can imagine the virtualization concepts networks. I can install in virtualization, we did VMware workstation, and VM workstation, we created a virtual machine and created a number of CPU and other things. But how the network is going to happen, how the storage is going to share the storage, what are the components are available, all those things we are going to discuss tomorrow session. Tomorrow session is all about storage concepts and network concepts in detail. Then I'll go with virtualization, starts with virtualization concepts. So first in this particular session, you need to understand starting how the applications are sharing the resources of hardware. If you understand application resource sharing, then you are replacing these applications with virtual machines. So that you should concentrate, you should understand physical components and applications, how the things are working, how the resources are sharing happening. Then only you can imagine in virtualization how the resource sharing is happening. Okay, that's it for today. Signing off. Bye.